Hello viewers, tutorial 10 question 3 and we're solving trig equations here. We are working in radians. We can tell that by the fact that our range is listed as being between 0 and 2 pi. Also notice that in the two questions that you can see on screen at the moment, the contents of the bracket are only x. It's sine of x and 2 cos of x. So we don't need to worry about a w here. We only need to worry about x, which means our table when we get there only requires 3 columns. Okay, so to solve for x, the first thing we need to do is take the sine inverse of both sides. So x is sine inverse of 0.5, and when we calculate that, we will get our theta, which is, doing the calculation gives us 0.5236. And if we divide that by pi, we get exactly 1 over 6, which tells us that what we've got is pi over 6. Okay, so we have our value of theta. We are now ready for our table. So we've got a column for n, we've got a column for x, that's the working column, and we've got a column for x, which will be where our final answers go, the solutions go. Okay, so for n equals 0, if n equals 0, n times pi is 0 times pi is 0, minus 1 to the 0 is 1, so this just becomes 1 times theta, which is pi over 6. And that will give us an answer of pi over 6. For n equals 1, so n pi will be 1 times pi plus negative 1 to the 1 multiplied by pi over 6, and that will give you 5 pi over 6. N equals 2, so n pi becomes 2 pi plus minus 1 to the power of 2 times pi over 6, which is going to be 13 pi over 6. So this has gone over 2 pi, so this solution is too big. These two are within range, they're between 0 and 2 pi, so those two solutions are good. And let's backtrack to negative 1 just to make sure we get negative pi, because n is negative 1. This becomes negative 1 times pi, which is negative pi, plus negative 1 to the negative 1 times pi upon 6. So this is minus pi. Minus 1 to the minus 1 is minus 1. So this becomes negative pi minus pi over 6, or negative 6 over 6 pi, minus pi over 6 is negative 7 pi over 6, which is too small. Okay, so we've got our solutions to sine of x equals 0.5, pi over 6, and 5 pi over 6. Now question B here, we've got cos of x equals the square root of 3. So if we divide both sides of that by 2, we get cosine of x equals the square root of 3 divided by 2. Solving that for x, we get cos inverse of square root of 3 divided by 2. And if we calculate that, we'll get theta, which is exactly the same number. It turns out we get pi over 6 again here. Okay, so we've got theta. Now we can work out our values of n, which are going to be, got to give ourselves a bit more space here because we've got a plus minus in the cosine formula, which means every n returns us 2 solutions. So we've got an x working as before, and we've got an x answer. So if n is 0, this is going to be 2 times n times pi is 0, plus or minus theta. So we just get plus or minus theta, so we'll get solutions of negative pi over 6 and positive pi over 6. So we've got negative pi over 6 and positive pi over 6. Don't really need to do any modification to get from working to answer because we've already actually did the working by identifying that bit 0. from the fact that n is 0. Okay, so minus pi upon 6 is too small, so this solution is too small, but pi over 6 is good. Okay, and n equals 1. If n equals 1, we've got 2 times pi minus pi over 6 and 2 pi plus pi over 6. So 2 pi minus pi over 6 is 11 pi over 6, and 2 pi plus pi over 6 is 13 pi over 6. So that solution is good, but this one is too big. So our solutions there are pi over 6 and 11 pi over 6. Okay, so we've got those two sorted. Now we've got a third equation to solve, which is cosine of 2 pi of 2x minus 6 equals 0.7. So we'll need to work out our w here. W is going to be the bracket, which is 2x minus 6. So that makes, if we rearrange that, we get x equals, add 6 to both sides. So 2x equals w plus 6. Divide that by 2. Okay, so far we've got cosine of w equals 0.7, and therefore w equals, if we take inverse cosine of that, we get cos inverse of 0.7. Calculating that will give us our theta, which turns out to be 0.795. Okay, so we'll create our table. Because we've got a w here, we need 4 columns. So we've got a column for n, we've got a column for w with working, we've got a column for w, which is the answer, and x, which is going to be w plus 6 divided by 2. Because of this plus 6 divided by 2 bit being relatively large, I'm going to start with n being negative 1 here. So for n being negative 1, we get negative 2 pi, because n equals 1 makes that 2 times minus 1 times pi makes this negative 2 pi, minus 0.795, and minus 2 pi plus 0.795. If we calculate those, we get minus 7.078 and minus 5.488. Okay, so if we do the calculation, so if we substitute minus 7.078 plus 6, divide that by 2, we get negative 0.539. That solution is too small, but if we work out negative 5.488 plus 6, divide that by 2, we get 0.256, which is within range. It's between 0 and 2 pi. For n equals 0, so this is going to be 2 times 0 times pi, which is going to be 0 plus minus theta. So we'll just get minus theta, which was 0.795, and positive 0.795, which will be your w with answers. And if we calculate that, we get 2.603, which is within range. And the next solution will be 0.795 plus 6. Divide that by 2, we get 3.398, which is also within range. And for n being 1, so if n is 1, we get 2 pi plus minus 0.795. So 2 pi minus 0.795, that will be 5.488. And if we work out that plus 6 divided by 2, we get 5.744, which is within range. And the next one would be 7.078. So that plus 6 would be 13.078. So if it was 13 and divide that by 2, we'd get 6.5. actually a little bit more than that, so it's definitely over 2 pi. It's too big, so the 2 pi plus solution is too big. So we know that we've got all of our solutions now. Okay, thanks for watching. Over and out.